Today in this video lecture, we're going to be solving this problem, find minimum in rotated sorted array. So in this problem, we're given an array of length n sorted in ascending order, and it is rotated between 1 and n times. Okay. For example, let's take this array, that is 0, 1, 2, 4, 5, 6, 7. It might become 4, 5, 6, 7 and 0, 1, 2 if it is rotated 4 times. So last 4 elements will be pushed to the first at the very beginning of the array. Okay. So in this fashion, the array is rotated. Notice that rotating an array one time results in the array a n minus 1. So that means the last element of the array becomes the first element of the array if I rotate an array one time. So you're given a sorted rotated array nums of unique elements. We have to return the minimum element of this array. So let's see how we can do that. And it is also given that you must write an algorithm that runs in O log n time. Okay, so let's better understand the problem statement using an example. So here let's take this example. We have an array of length 7 and it is rotated 4 times. The original array is 0, 1, 2, 4, 5. Now I want to find the minimum element in this rotated array. Since this was a sorted array, the minimum element would be the very first element in this sorted array, and here in this rotated array it would be this one. So how can I find this minimum element? One of the ways to do so is just a traverse over the array and fine. Now how can I solve this? One of the ways is simple, use linear traversal. So traverse this array and just check for the very first element which is less than its previous element. So that is this 0 in this case, and the complexity for that algorithm is big of n, because in the worst case we may have to traverse all of the elements of an array. Okay. Now what is the efficient algorithm to solve this problem? The efficient algorithm to solve this problem is basically binary search. We can solve this problem using binary search. How? Let's see that. So we'll take 2 pointers. First pointer at the beginning of the array, second pointer at the end of this array, which defines our search space. Now find the middle element. Find the middle element. For this it would be 0 plus 6 by 2, that is the third element, or the element at the index number 3, which is 7. Now there can be, now we'll consider 2 cases here, or rather 4 cases here. The first one is if the middle element itself is the minimum element. If it is the case, then it must be smaller than its previous element. Okay, here in this case 7 is not smaller than its previous element, so this mid is not the minimum element. That the element next to the middle element is the minimum element. So for that we have to check for the element next to the middle element, that is the element number mid plus 1. So we have to check if the element at mid plus 1 is lesser than the element at mid. So for this case it is the case 0 is less than 7, so we return 0 in this case. Fine. So these are the 2 cases. Let's take third case. The third case is that when we do not encounter any of these 2 cases. So like say we have mid here, we have mid here, we get our mid at the third element of the array. So in this case, how do we check? We simply compare this element with the first element of the array. Now if the element here, like here it is mid element, now if the mid element is greater than the first element of the array, that means we are on the rotated side. So this side is rotated. Fine. That means the minimum element will lie in the range from mid plus 1 to R. Okay. That's what I conclude. Hence, I reinitialize my range to mid plus 1 to R. Fine. Let's say I come across an element here, okay, like towards the right of the minimum element. So this was the case for the element which lies to the left of the minimum element, while this is the case with where our mid pointer is placed at an element which lies on the right side of the minimum element. So here in this case we can see that this 1 is smaller than the first element of the array. That means that we conclude that we are lying on the right side of the minimum element. Hence, the range will be reinitialized to L2 mid minus 1 because the minimum element lies in this range. Fine. So in this fashion, we will eventually find our minimum element while we perform the binary search over the array. Fine. So that's the approach to find the minimum element in a sorted rotated array. Another edge case is that when the array is not rotated, when the array is rotated 0 times, like here in this case, this type of array. Now, to handle this condition, we simply check if the first element is lesser than the last element. So, if an array is not rotated or it is rotated 0 times, then the first element of the array is always lesser than the last element. Otherwise, it will be greater than the last element in case of a rotated sorted array. So, we have to check for these two conditions. Okay, so let's just okay, so check for the very first condition. When we have only single element in the array, then return that single element itself, so nums of low. Otherwise, if we have, let's check if the very first element of the array is less than the last element of the array, return that first element from the array. Fine. Otherwise, perform binary search, find the middle element. Now, the very first condition, if this mid is the minimum element, in that case we have to check if its previous element is greater. So if mid minus 1 is greater than equals to 0 and nums mid minus 1 is greater than nums mid. So in this case we return the element at the middle index, or otherwise, let's say if the element at the next index of the middle element is the minimum element. That means nums of mid plus 1 has to be smaller than nums of mid. If it is the case, return the element at nums of at mid plus 1. Otherwise, check if we lie, if the middle element on which we are standing is greater than the very first element of the array, then that means we are lying on the left side of the middle element. In that case, reinitialize the range to mid plus 1 to high. Otherwise, we are lying on the right side of the array, right side of the minimum element, and then reinitialize the range from low to mid minus 1. Fine. Like if we do not find our, like here at the end of this function, return minus 1.